lecture. Today we're going to talk about SwiftData. And so some quick announcements. So the form for the final group project is due like right now. So if you haven't filled out the form, please do, or else we're just going to randomly match you. Okay. So if you have a preference, please make sure you fill that form. And once we do send the groups sometime today, please start emailing your group team to establish the best way of communication and do it early because uh you will have the next step is where we're going to basically give you what the final project specs are and what you need to do. And what's due next Monday is a proposal of your idea by your app and also Figma specifications. So you're going to be working on a Figma kind of project together and you'll be kind of hashing out the design. Now, for the design, we're not expecting you to be like a really polished, very beautiful kind of Figma. I mean, if you have the time to do it, feel free so. But what we're looking for is like more of a, what are the tabs of your app, right? What is on your home tab? Um, kind of like bigger picture ideas. So you could like create a wireframe. That's fine. But yeah, so the you're gonna have a Google Doc of your idea proposal about your app, and then you're gonna have a Figma project that you have to do, and you're gonna submit that link as well. So we're gonna get these up sometime today. But yeah, that's the next task. And again, if you have any issues with your team, feel free to create a private post so that we could resolve that as soon as possible. Okay. Any questions about the final project? Good. Okay. So for today's agenda, we're going to talk about SwiftData. And SwiftData is a framework where you can save data locally on your device. So we're first going to talk about what data persistence is, and then we're going to talk about how SwiftData works, how SwiftData is built using macros, different kinds of operations that you can use on SwiftData. And then we're going to do a quick demo with, I think you've seen this app before in one of Dylan's discussions, but it's like a sticky note app. Okay. So currently our apps lose data when we quit and then restart. So for example, if you have a to-do list app, right, and you quit your app, you kind of slide in the middle of your iPhone and then you swipe up to quit the app. And then when you restart again, all of your data is lost, right? And the reason is because all of our data is saved in our view models or at state variables, and they'll live in memory, right? But they're not persisted on the device. So this is a question of data persistence. So we want our data and associated info, if it makes sense, to persist between restarts, right? For example, like a to-do list app, right? I think it's a really terrible app if your to-do list app, every single time the user launches your app, all the information is gone, right? We want to save the data. Now, in iOS, there's many ways to save data. Uh, One of them is a framework called user defaults. I don't think well, it's not a framework, but well, it's built well in Swift. There's I guess a framework, whatever, called user defaults, and these are like key and value stores. You could save a key and value pair, and these are for like very kind of general system or like your app data, like settings data, for example, like oh, how many app launches did the current user have on this device, or what option did they select in settings, like accessibility. And it's very like you have a string and then you have some value that you have a key and value pairing, basically, like a dictionary. You could also save data to a file on device. So maybe you have a game, for example. You want to save your data to like some file locally. And then every single time the user opens or launches the game, it will basically decode the file and then restore the game state. Or, for example, an app like GoodNotes or Notability, you're saving those files or documents, as like regular files on device. So there's another framework called Core Data, and this is more a bit of a antiquated framework, but it is basically a object graph kind of persistence framework where we represent objects as objects, and it's you kind of encode the relationships between objects to save. It's a bit kind of very messy. There's a lot of things that need to get Yeah, there's a lot of like kind of scaffolding code that you have to write in order to support core data. But a lot of the more kind of, again, more of the more complicated apps, they probably use core data. But we're going to use something called SwiftData, which is introduced relatively recently in iOS 17. So maybe like 2 years ago, 2.5, 3 years ago. And this is so simple because of macros, and it's built in mind with SwiftUI, and you don't need to think about all the kind of abstraction layers. It just works right from the box. And I think for every simple app, SwiftData is so intuitive to use. So what are some examples of data persistence? So like I mentioned, a to-do list app, right? Like things, you want to make sure that every single time user opens your app, data is there, not kind of, not with an empty screen, right? And then, for example, our note-taking apps like GoodNotes, where all the data is saved locally, and and all of these two things are synced with iCloud, probably using CloudKit. Um, but the idea of data persistence on device, it's still there because if, for example, if you have no Wi-Fi, right, you're still able to, you know, add changes to your GoodNotes document. It's still there, right, because it's saved on device. And then once there is Wi-Fi, it then syncs up with the cloud and everything, right? So, yeah. So that's a quick kind of overview of data persistence and why we want to have data persistence. Next, let's talk about Swift Data. So Swift Data is a framework, and it is built on top of core data. So core data is, again, it's that old, antiquated, well, it's still in use, but it's kind of an old, more object-oriented framework. Um, it's been here since iOS 3.0, and it's used to persist or cache data on a single device. And you could use CloudKit as another framework where you could sync data to multiple devices. Models. So in core data, we model data using objects in an object graph. So and we're able to encode different types of relationships between those objects. So, for example, let's say we have, like a school, and then that school has an array of students, and then you have a school object, and inherently you can model that relationship in a graph structure or data type. Again, it's quite complicated to get up and running because in Xcode you have to create a special file where you do all that configuration and all that stuff. And then you have to, the API is a bit more complicated where you have to, load data from core data in a way and then, pipe it throughout your app. So again, it's a bit messy, but that's core data. So Swift data builds on top of core data because it uses core data under the hood, but it abstracts away a lot of the kind of the complicatedness of core data and gives us a very simple, intuitive API built for SwiftUI. Um, and it leverages macros, as we talked about kind of like two lectures ago. And yeah, I think it's very expressive, and for simple apps, it does the job. So introduced in dub24. Uh, I think was it introduced in dub24? I think that's the typo. It should be dub23. To iOS 17. This is iOS 18. Um, and like core data, so it's a framework that allows us to implement data persistence. Again, under the hood, it uses core data, which is the object graph, but we don't really interact it with that directly. It's very simple to integrate with SwiftUI, and we can basically fetch and query items from the Swift data store through specified rules. And those rules are what we call predicates. So let's say I want to fetch all of these items, all these students with an ID of so-and-so, or age group of so-and-so, or grade of so-and-so. So we can really easily can query items from the data store with some specified rules. So what can you use it for? Of course, permanent storage of users' data. So for example, to-do list app. Maybe you're making a recipe cooking app. You could save each recipe in Swift data. You could also maybe save it for temporary storage of user data. For example, like cache for data fetched from a server. Again, usually keep it in memory, right? As like an array or something or dictionary, but maybe you want to have some kind of long-term temporary storage of user data that works as well. And then you get purge it later on at some point, future point of time, given a condition. And then, of course, document-based apps like GoodNotes, Procreate, Notability, and things like that. Um, I guess for example, for more complex user settings or history data, you could use SwiftData. Um, in more recent APIs, you could kind of compare different snap points of the SwiftData history, and you could kind of see what's changed or what's not. But yeah. So again, SwiftData is a less of a great choice when you do support users using iOS 16 or earlier because, well, SwiftData is available on iOS 17 and above. And if your code needs to be stored on the cloud, maybe a better option is using more of a cloud-based storage like Firebase or Supabase, or you could use SwiftData with CloudKits to kind of do the syncing as well. But again, it just depends on what your app kind of requirements of your app, right? Oh, and of course, if it's cross-platform app, for example, if you're targeting Android and web apps at the same time, maybe you should use something else like Firebase or some kind of other cloud storage provider. Okay, so that's a quick look of SwiftData. Now let's talk about the macros in SwiftData. So just to review, again, we talked about this in a previous lecture, but how does code get run, right? So our code, when we write code, right, in Xcode or whatever, it's just basically text. It's just a bunch of characters and spaces. To the computer, it doesn't know what the heck it is, right? It has no concept of what you're trying to convey because it's just like a Word doc, right? So how does that computer make sense of your text? Well, it goes through this process called compiling. So whenever you heard of compiling your code, that means your text files are going through this program called a compiler that translates your text into machine code. Okay. And when I mean machine code, that means like binary ones and zeros, or usually it's translated into assembly, which is a very low level language that is specific to the architecture of your computer. Okay. So, for example, MacBooks are built around the ARM chip architecture. So, ARM has a set of assembly language specific for this computer or chipset. If you have Windows, if you're using Intel, it uses an architecture called x86, and x86 has its own assembly code. So, what the compiler is doing is translating your text into that low-level code for your computer to be understand. So it goes through the compiler, and then it basically, creates some machine code, usually, and then, it creates, usually this machine code is like an executable that makes sense for your operating system, and the operating system basically runs your program and loads your executable and runs it basically. So that's kind of the whole pipeline of how codes gets ran. And so every single time in Xcode, when you're clicking that run button, in the top, you can see it says compiling. Well, that's what it's doing. It's translating your code into this kind of executable file that you're basically can be ran on iOS. So macros adds it's a feature where you could add or generate hidden code. So the main difference between this and property wrappers are like at state, um, let's see, at binding, and those are basically performed during runtime. So there's a concept between compile time and runtime. Compile time is when it's actually compiling through the compiler. So that's before the program gets ran. So it compiles first, right? And then the program gets ran. So there's like kind of two parts. Property wrappers function during runtime because the data that's it's acting upon is dynamic, right? It could change during the runtime of the application. Macros are in the first part where it generates code during compile time, okay, before the code is actually being ran. So what it does is that it adds new code alongside the code that you wrote. It never modifies or deletes your code. Okay. So what kind of Apple or third-party developers can create macros, and you could use them within your project to kind of inject code before the program gets ran. And it's like a very nice kind of it abstracts a lot of the kind of more nitty-gritty details that you might need. Um, and we've seen this with like observation, right? With at observable, right? We don't need to know how at observable works. we just add it to our class or struct, whatever, and it's observable, right? And so when you click on the macro, you can see all the code that it injects. So we have a regular source code, right, or text file, and then when we add a macro during compile time, it will inject the code into our existing code, and that would be part of our program. So how does macros get injected? We call this expanding macros. So before the compiler, there's another kind of stage called the preprocessor, whose job is one of its job is to expand all these macros. So we represent our code in like a tree structure, like a node, like a tree structure, like So for example, we might have like two items that we want to add together, right? Like two, and then here is like a operator, like a plus, and this is like a string. So because of this tree structure, we're able to analyze, hey, you can't add an integer with a string, and the compiler throws an error, and we could see it, in Xcode, right? You can't add a string with a number, right? So our code is represented via this kind of tree structure, and during the preprocessor, before the compiler, it injects these kind of new code within the tree, and that becomes part of our new kind of code, um, tree. Um, okay, so okay, that was a quick review of what macros are. Now, all these kind of macros, again, all the next things I'm going to talk about are macros, okay? So you basically attach it to something, and it will, during compile time, it will inject code for us. Okay, so the first macro that we're going to learn is called @model, and it basically transforms a model, like your class, your struct, into ones that can be persisted. So it also automatically transforms stored properties as well. So for example, if you have properties on your model or your class, your struct, whatever, it will allow it to be persisted as well. Under the hood, what it does is that it conforms to this persistent model protocol, and it makes it also observable as well. Again, we don't need to know anything about that. We just add @model, and it just does the thing for us. And again, it supports types like Boolean, integer, strings, and etc. And for more complex types like structs, enums, and other values that um, um, you need to conform to the codable protocol in order for it to decode and encode data correctly. So this is what it looks like. So for example, let's say we are making like a trip planning app, right? We have a class called trip, and these are all of our properties, right? All we need to do is need to annotate this trip with an @model macro, and that's it. And because of that, this trip class can be saved or stored using SwiftData. It's that simple, right? @model. Again, we don't need to know what @model does because again, it kind of when this program gets compiled, it will inject a lot of code within here, but we don't need to worry about that. Okay, we just add @model, just like how you make a class observable with @observable. You just do @model, and there you go. Your class or struct, whatever, can now work with SwiftData. The second macro is called an @attribute, and @attribute basically modifies a property of a model class. Okay, so you can customize how SwiftData works with the property in this class. So here are some things that you can customize. You can basically mark a property of a class to be unique. So it basically makes sure that, when you're saving an instance of this class into SwiftData, that every single instance whose property is marked unique is unique. Okay. So you can't basically insert two items into SwiftData with the same, for example, if you mark this attribute unique on an ID property, it will ensure that all the instances that you give in or save into SwiftData, ID property is always unique. You could also basically say, I want to make this property available to Spotlight. So, for example, I guess when the user is, when you search something in Spotlight, you're able to kind of surface information through your app. And there's another kind of version where it's called ephemeral, which basically means that I want to track changes to this property, like make it observable, but don't save the data of this property. So for example, maybe you have a property that's like, just for like again, it's not important, it's just kind of like intermediate, it's like saving data or like, it's like a computer property where it's like the property value is derived from the other properties in this class, but you don't need to save it, right? It's just there to help you with your code or whatever. You could attach this attribute ephemeral and it basically says, you still track changes to this property, but don't save it into SwiftData. And there's so much more. So you can feel free to check out the documentation if you want. Um, Here we have another macro called @transient, and it's usually used for properties that may only ever contain temporary data that does not need saving. Um, so this is sort of like the ephemeral thing, but you just basically in front of the property, you could just do @transient, and SwiftData won't write the values or won't save the data basically. Okay. So those were kind of three macros. Again, there's much more, but those are just kind of the three main ones. Next, let's talk about relationships in SwiftData. So your data can, well, as you're building out your model, right, you might see some relationships between two different classes or whatever, or even more. So there's kind of three main ones. One of them is a one-to-one relationship. So what that means is that you have these, again, two kind of objects, two classes, right? And it's a one-to-one relationship. So one person has okay, let's just pretend we're in a world that um each person only has one passport. Okay, I know that one person might have multiple passports, but let's just say in a world that each person can only have one passport. Well, we have a person, right? It can only have one passport, and one passport belongs to one person, right? So that's an analogy of one to one. Um, So here we have another one called one to many. So this is, for example, directors of movies. Well, one director can have multiple movies, right, that they produce. And then that each movie is tied back to one director, right? And then finally, we have a third kind of relationship is called many to many. So it's like films and actors, right? You have a bunch of films, and each film has a bunch of actors that belongs to that film. And then for each actor, that actor could be in multiple films, right? So it creates this kind of graph structure where um, if you have taken CS70, this is like a bipartite graph. Um, you know, these are two like disjoint sets. Yeah. Anyways, so these are kind of three relationships that you might see your data kind of fitting in between, right? So let's take a look at the one-to-many relationship. For example, okay, here we have these two classes, movie and director. And on the movie, we have like name, release year. We have a director property whose type is director. And then here we have a director. The director has a name, and a director has a list of array of movies, right? So again, we have a movie has a director, and a director has a list of movies. So okay, so in Swift data, there are again we've seen those three types of general relationships of data, right? Um, so in Swift data, there's kind of two types of relationships between like two objects or two classes. One of them is called inferred relationships. So by marking this director as optional, what that means is that Swift data can infer its relationship in movie to the director. Okay. So what that means is that on a movie, right, we could assign a director to the director properties. For example, I could say movie.director equals Steven Spielberg. And what that does is that, okay, we assign Steven Spielberg to this director property in movie, right? Well, since it's inferred, right? Again, there's a relationship between movie and director. When you do this on a movie, it automatically adds the movie to this Steven Spielberg instance, right? So, for example, Steven Spielberg is a director, right? Currently, we assigned the movie property, sorry, director property in movie to Steven Spielberg. So, because of marking this as an optional type, uh, Swift Data is able to understand that Steven Spielberg, again, Steven Spielberg has a list of movies, right? So it will add the movie into Steven Spielberg's movies array, if that makes sense. Okay, so it does two things at once. Um, Does that make sense, kind of? Okay. So let me rephrase that again. So again, a movie has a director. A director has a list of movies. Here, we're just assigning the director property to a director, right? In this case, Steven Spielberg. So, okay, this is set. But since we mark this as an optional, oops, since we mark this as an optional, it's able to infer the kind of other side of things, right? So it will automatically add this movie to Steven Spielberg's movies array. So they're kind of in sync, if that makes sense. And you could do it vice versa. Maybe instead of this, you could write Steven Spielberg dot movies dot append movie, and it will add that movie to Steven Spielberg's movies array, right? And then since it's inferred, you could say, oh, this movie that we append to here, its director will be now Steven Spielberg. So you could either assign the director property on a movie, or you could directly modify um, the movies array of a director, and it will automatically assign the director to that movie. Kind of, yeah. The next kind of relationship is explicit. So again, you can basically, okay, in this case, if you use an explicit relationship, you don't need this optional anymore. You could just remove it and make it non-optional. Since we have this explicit relationship that SwiftData doesn't need to infer. So what you could say is that you could specify the relationship explicitly by specifying the inverse. So you do at relationship. Again, this is a macro at relationship, and then here you have this property. Sorry, this argument called inverse, and you specify the inverse of this movies array, right? Well, what's the inverse of this movies array? It's the director, right? So okay. So again, we have this relationship between a movie and its director and director and its movies, right? And so on the movie, we have this director, right? So we're just basically specifying the inverse of this movies array is this director property on a movie. Okay. So you're saying we have this connection there. Now with this at relationship macro, it also specifies a delete rule. So by default, it uses this delete rule called nullify, which means that if you, for example, delete a movie from this movies array on a director, it will mark this director with a nil, right? But the actual data of the movie stored in SwiftData is still there. So when we delete a director, we automatically delete all movies instead of setting each to nil by default. So what this means is that if you don't specify this cascade, when you delete a director, right, and let's say this director has a bunch of movies saved in SwiftData, by default, it would just mark all these movies director property to be nil. It's still there, right? But when we want to delete a director, we want to delete all of the movies that's saved in SwiftData. So by saying delete rule equals to cascade, what that means is that it will sort of cascade downwards, right? Where all of the movies associated into director will be deleted from the SwiftData store. Okay. Um, and again, let's say you have more of a nested relationship where, a director has an array of movies, a movie has maybe another property that's like another class, like movie metadata, whatever. With Cascade, it's able to delete all of the kind of hierarchy. So it would delete all of the movies from the data store. It would delete all of the metadata that we have here as well. So it just keeps on going if we have any kind of references. So yeah, usually if you have some sort of kind of a relationship like a one-to-many, you should specify using at relationship delete rule cascade instead of nullify. Because again, if you by default it's nullify, and what that means is that again, if I delete a director, right? It will just again the movies are still there saved, but it will just basically assign the director to be nil. It doesn't delete them; it's still there. So by saying delete rule cascade, when we delete a director, it also deletes all the movies saved in SwiftData. Okay. Okay. So then we learn at model, we learn how to configure different properties on a model, right? So we need to create the SwiftData storage or container. And we use a model container view modifier on like the root view hierarchy of your views. So a model container is responsible for creating and managing the actual database file used for all SwiftData storage needs. So again, under the hood, SwiftData uses like a file to manage all of your objects that are saved in SwiftData. And so the model container is basically a place where the system can read and write data to. And all we need to do is to create it, we use the dot model container modifier and we attach it to the top of the view hierarchy. Where's the top of the view hierarchy? That's like, for example, in your entry point into your app, your at main, and then the app protocol with the scene, right? Your window group, that file. You should attach it under there. And all of the nested views will inherit the properly configured environment. So all of the new nested views that this model container is attached upon can access it. And we basically specify an array of model types we want to persist. So basically, when we attach this model container view modifier, we pass in a list of array of types of our data, basically saying, hey, this model container supports X, Y, and Z types that we could save into it. So this is what it looks like, right? For example, here, again, this is our entry point into the app, right? That we all know. Again, here's like the first kind of screen that our app launches, the content view, whatever, or whatever you want to name it. And then on here, we create this model container. Again, the model container creates the database file that SwiftData reads and writes to. And then here, one of its kind of versions is to supply an array of types of data you want to save into here. So we're going to save trips. We're going to save this accommodation data type into here. Okay. Um, so what this also does is that it creates a model context for us to access the stuff saved in the model container. Okay. We don't really interact with the model container directly. We interact it with via the model context. So the model context is like kind of the in between of how we interact with the model container or interact with the stuff stored in SwiftData. So again, when you're fetching stuff or when you're modifying stuff, when you're saving stuff from SwiftData to and from SwiftData, you're doing it via the model context. Okay. So the model context tracks changes to your models and provides various actions to operate on them. So for example, you could track updates, you could fetch data or query stuff from SwiftData. You could save stuff or delete stuff from or via the model context. And you generally retrieve the model context from your view's environment. So, like again, we create the model container on the very top view of your view hierarchy, right? And then all of its subviews have access to this model context kind of thing now. And you'll be doing operations, or if you're changing something in SwiftData or you're getting stuff from SwiftData, you access it via the model context from the environment. Um, okay, so that's a quick look of kind of the different stuff that you can configure for SwiftData. Now let's talk about kind of the SwiftData operations. So again, we can fetch stuff from SwiftData by querying things, and we could specify the kind of stuff that are rules of how we want to query things via a predicate macro. So a predicate macro allows us to filter a wide variety of operations. For example, data loaded through this at query macro. At query is how we basically query items. And then a predicate allows us to kind of specify exactly what we want to query. Um, we could delete model objects using the delete method on a model context. And okay, so this is what a predicate looks like. So we have today's date. Here's a predicate. Again, there's a macro. And within the closure, we basically specify kind of what we want to fetch. So what we're saying here is that we want to fetch trips whose destination is New York, whose name contains birthday, and whose start date is greater than today. Okay. And the predicate here, you basically enter the type of the stuff that you want to fetch. So this, again, this is a rule, right? We want to fetch our trips based on this condition. Uh, so then, so this basically says filter all trips whose destination is New York and name contains birthday and starting date is greater than the current time. We use query in our SwiftUI views to fetch the data. So SwiftData and SwiftUI will work together to provide light updates to your views. So for example, when some of the underlying saved data changes, it will automatically update your views. So you don't need to think about that. So this is what it looks like. We have this at query bar recipes and then the array. So the type, which is an array of recipes, and then we basically use it within a list. And that's it. So what this at query macro does is that it basically will automatically query all of the saved recipes in our Swift data and display it in our list. That's it. If you want to use a query and a predicate, this is what you will do. So there's a filter version, okay, that query takes in, and you basically pass in a predicate. So what this is saying is that we're querying an array of movies, right? We're querying all the movies stored in Swift data based on this condition. We're filtering it based on this predicate. So we're basically getting all the movies stored in Swift data whose director name contains Steven and whose movie cost is greater than this number, right? And then query will get all those movies that satisfy this predicate, and then we could use it in our views. And if one of the names of this model movie changes, it will automatically re-render and update without you have to do anything. So we could delete and insert things, right? Again, when we're modifying Swift data, we interact it via the model context, okay? Model context is the way you interact with Swift data. So uh, this is what it looks like. So for example, here we have our at environment, right? In our view, here we create a new trip, right? And then to insert it into Swift data, we use context.insert our new trip. And then you would save it via try context.save. So to save the data in Swift data, again, once you insert it or delete things, it doesn't save it right away. You have to call context.save. And the reason is because saving stuff persistently on device is a very expensive operation. If you have taken 61C, you probably understand why I'm saying this. But in general, when you're saving things on device, it's a very expensive operation. And so here, when you're basically doing context.insert, you're not actually saving it to Swift data locally on device. It's kind of moving things into kind of an intermediate stage. And then when you do context.save, it saves all of the things that you have queued up at once. So let's say we create 1,000 trips, right? Well, when we're creating 1,000 trips, we don't want to save to the storage, 1,000 times. We could insert all these trips into a context and save them in a batch at once. Okay. Now this code doesn't make any sense because you're inserting it and then you're deleting it and you're saving it. So in this case, it doesn't really save anything. But I'm just kind of showing you the insert and delete. So basically, um, for example, if you want to delete something, you just basically pass in that instance into this delete method and you save it and it will delete it from Swift data. And then your at query or whatever will update because the underlying Swift data container changes, right? The data changes and then we'll just automatically update. Okay, so we have I don't think we have much time, but we're gonna do a quick demo of stickies. So again, you probably have seen this application from one of Dylan's prior lectures, but now we're gonna add data persistence to our app. So if we take a look at an app right here, right, our we have our stickies right here. Um, right. Again, our sticky, just to remind everyone, it's a sticky note. It just has a text, information about its position, that's width and height. It has information about like the Z index of like where, what layer it should be in, right? The higher the Z index, the more, I guess, visible we want to see at the top. Okay, so what we do is that we basically, to make this observable, to save this, we import Swift data and we annotate this at model, and that's it. Once we add at model to our class, what we're saying is that sticky is able to be persisted in Swift data. And I can right click on this and I could save, I could say, um, where did it go? Expand macro. Again, under the hood, when the program gets ran, right? When it's compiling, all of this code is being injected into this file, okay, for us by SwiftData. Okay, there's a lot going on. Again, I don't need to know any of this. It just automatically injects it for us so to make SwiftData possible. But that's what happens when the program gets compiled. Okay, and I can just hide macro expansion. Okay, here is our kind of our entry point into the app, right? So this is the first thing that gets loaded. And on the root view hierarchy, again, the first thing that our app launches is our content view. And on this, we're going to basically create our model container. Again, our model container is basically creating the model context and also the data file that SwiftData uses to save our objects locally. So what we're saying here is that we create a model container that supports what type of data objects? Well, we want to support our sticky. So we basically do sticky.self. Again, this .self means the type. This array expects a type of data, not the actual data, but the type of things that we're able to save into SwiftData. In this case, just stickies, okay? So now since we do this, content view, we can get access to the model context. Again, we do all the stuff via the model context. We don't interact with the model container directly. We interact the stuff in SwiftData via the model context. And so because of that, we now can have access to the model context. We get it from the environment. Again, it's injected into content views environment. And then again, all of content views subviews also inherent content views environments. It also gets the model context. And this is simply the just like this private var model context. So now we have the model context. So here we have an array of stickies, right? But this isn't at state. This is in memory. So when the user quits the app and relaunches it, every single time the app launches, we have an empty array, right? We don't want that. We want to fetch all the stickies in SwiftData. So instead of at state, we use an at query. And then we just basically specified what type stickies is, which is a bunch of array of stickies. And that's it. So with this at query macro on stickies, it's going to automatically query all the stickies saved in SwiftData for us and then pipe it into our views. And whenever one of the sticky changes, it will re-update our views automatically without having us to do anything. So then, okay. So um, okay, so now let's just kind of run our app just to actually let's just yeah, run our app to see what it looks like. Um if you recall, we have this kind of button in our top right-hand corner where we basically create a new sticky, right? So here is basically in our toolbar item, right? We have a button and we want to create a new sticky and insert it into our model context. So um uh, Okay, so what we do here is that we will create a new sticky. So let new sticky equals sticky, and its z index is going to be initialized to how many stickies we have currently. Okay, and what this does is that it's going to basically put the sticky at the very top. Um, okay, and then here we need to insert the sticky into SwiftData. So how do we do that? Well, we do it via the model context, and we do insert our persistent model, which is our sticky, and then we need to save it to SwiftData. Again, this doesn't save it automatically. We have to save it manually. And so to do that, we use model context dot save. And as you can see, save is throwable, which means that it could throw an error. Well, because what happens if something goes wrong when we're saving? So we could do a do catch to kind of catch the error if necessary, and maybe we could show an alert. But for now, we could kind of ignore it using try using this. We can just basically do try optional, which means that if this fails, it will just kind of fail silently. If we remove the optional here, um, this would say we would call save, but we need to handle the error. Okay. But to kind of silence it, we could just use try optional, just say, hey, if it fails, okay, it's fine. Don't worry about it. it would just kind of fail silently like that. Okay, so that's how we can create a new sticky and insert into the model context. So let's say we do this now. Yeah, okay, so now when we let's reload the app since we have implemented this now. So theoretically, we should see all of our stickies show up. There we go. You could see it, right? And now they're all there. Two of them are there. So now if I quit the app, again, they're not going to be the same position because we haven't saved any of the position locations, but we should have two stickies show up. There we go. They're there now, right? So we have two stickies right there that are saved. Now let's save the position location of them. So let's go down here. And in our sticky view, we're going to get our model context. And the reason why we could do this is because, again, sticky view is content view is sticky view's parent, right? And so sticky view inherits content view's environment, which has this model context. So I'm able to get this model context there. Here, we need to create an initializer. So here we're passing a sticky, right? Here we have a bunch of at state variables like position, text, drag, offset, yada, yada, yada. We want to basically set all of these properties based on this passed in sticky. So to do this, we create an initializer that takes in a sticky and what we do is that we basically set all of these properties via properties of sticky. So again, there's a weird syntax that you have to do. It's, if I remember correctly, it's like something like this. Sticky.text. Text. Here we have position, state initial value, sticky.position. Okay, position size. Then drag. Okay, I think. Sorry, I think I need to check. See if I'm doing this right. Okay, it's just this. Okay, so it's just this. So basically here we're assigning the sticky to this variable. Wait, what? Yeah, we're basically so. Here we're creating a new initializer and it takes in some sticky. We're assigning this passed in sticky into this one right here. And then we're basically assigning the text and position from the values of the sticky that we get passed in. And again, these are at state properties. So we have to use this syntax where we're creating a at state. And then we have to use this underscore in front of each of these variable names to basically assign the state kind of the state thing that we created here to each of these properties. Again, it's a bit weird, but this is kind of the syntax you have to do. Okay, so now here, when we do the drag gesture, when we're dragging the things, we have to set the sticky position width and height. Again, just for time, I'm just going to copy this. Here we have, again, we're basically assigning the sticky position width to the position that we get from the drag gesture and the height as well. And then we're saving it to our model context, okay? So now it's when we run this, the positions should change. Sorry, should save. So let's move this here. Let's move this here. All right, quit the app, rerun it. There we go. Okay. So we get all, again, for each of these stickies, we pass it into here, and then we're assigning the position based on the sticky, the saved data from sticky, basically. So now they're where they are. Nice. Okay, here we have our Z index that we have. Again, I'm just gonna quickly copy this since we're running out of time. This basically sets the kind of like the Z, like what, I guess what if a sticky is on top of another sticky and I press on it, I want that sticky to surface up and I need to update the Z index of that, right? To show what layering it is. And then finally, we have this text value that changes the sticky text, right? Here I have the sticky text. So we when the text changes, we save it back to sticky. And then finally, we have the delete button here, which is basically here we call the delete method on that sticky, right? We call the delete method on model context. We give it the sticky and then we save it. So then everything should be okay. Um, so now I could type something. Let's call this yo. What's up? I could create another one. Uh, you know, anyways, so I have my stickies here. I can put it here, whatever. Quit it, relaunch it. The text should be there. Okay. And I could delete one. Let's delete this guy. Quit, relaunch, and the one's not there anymore. Okay. And I could, add an infinite number of more stickies. And based on how I press it, right, it saves the Z index, right? If I want this to be on top, it will be on top, right? So now this one's on top now. So if I rerun it, that yo should be on top. Oh, I guess it's not on top, but I think it's because we need to update it here when we pass in the sticky. But you get the idea. So that's something pretty cool. Anyway, so that's it for today. We didn't have time to do the poll, but that means you guys get free attendance for today. So yeah, this is really cool. I think once you kind of do it more, again, it's pretty simple. It's just kind of the steps and procedures of what you need to do. But that's how you save data locally on your device. So cool. All right, thank you guys. We're gonna have office hours now. If you have the mid-semester project you want to get checked off, please feel free to come up. But yeah, for those who are late, we're gonna release the group projects to